Abstract classes are a piece of functionality that I mentioned really for the first time in the video entitled Pure Virtual Functions. Now, if you watched that video already or you're familiar with pure virtual functions, then you're good to go here. If not, go back and watch that video and then come back to me here, okay? So start off with the bottom line. What is an abstract class? An abstract class is a class that contains at least one pure virtual function. Now, what exactly does abstract mean? And so you're probably already thinking, wait a minute, concrete, abstract. Concrete means something I can see, touch, feel, that sort of thing. Abstract means something, a little less solid. And in a programming sense, we're talking about a class that I cannot use to define objects. All right. Now, what that really turns into is a base class that simply must be inherited from to be able to use any of the functionality that might be in it. All right. So an abstract class is one that you must derive a class from it to be able to use it. Okay. So any classes, before you can use an abstract class, let me say it this way, you will have to build another class, inherit from your abstract class. Okay. Now, again, let me warn you, C# and VB.NET people, and maybe even some other languages, be very careful with C++. Some of these terms that you see, and you'll assume, oh, well, I know what an abstract class is and how you can use it. Be very careful. Go dig into the C++ world, because in C++, an abstract class can contain data members, meaning variables, and function members, meaning functions that do have code in them, along with pure virtual functions, and it's still going to be noticed as an abstract class, and you will see more of this in the example a little bit later on in a separate video. Now, when you inherit from an abstract class, all your pure virtual functions must be defined. Now, if you don't, the derived class that you're working from is going to be reported to you by the compiler as an abstract class itself. So the bottom line is, once I mark a function as a pure virtual function, then if it gets inherited into another class and I don't write code for it and I don't satisfy that pure virtual function aspect, then whatever class is inheriting from the base is going to be considered abstract as well, because it has an incomplete pure virtual function. I'm using the word incomplete kind of loosely there, okay? Now, the constant keyword that you use in defining a pure virtual function is also a condition of overloading. So if you leave it off, then the compiler is not going to consider that this is satisfying the pure virtual function definition, okay? So just make sure of that. You're going to have to match that signature pretty much exactly. Now, you haven't seen an example of what a pure virtual function looks like or anything, because I want to present the two ideas each in their own video and then come back and show you a pure virtual function example. So that's what we're going to do in a separate video, and you'll see a pure virtual function example out there in your work files folder, and then you'll be able to see exactly what's going on by going through that code. Now, the best way to understand this is to see it in an actual code example. So join me in the pure virtual function example video, and we'll take a look at one.